Willkommen, mein Name ist Peter Désilets von der Firma pacoon AG. Wir sind eine Designagentur aus München und arbeiten in Kooperation mit dem Dänischen Technologischen Institut. Und wir werden Ihnen jetzt ein paar funktionelle Packungen, Ideen vorstellen, basierend auf der Idee der Mikrowellenzubereitung. Und werden ganz nebenbei auch mal zeigen, dass man eine Pizza in der Mikrowelle kross backen kann, was wahrscheinlich die wenigsten von Ihnen annehmen. Und werden Ihnen auch ein bisschen erklären, wie das Ganze funktioniert und was man dann in Zukunft alle daraus entwickeln kann, was für große Märkte sich daraus ergeben könnten und geben auch noch ein bisschen Hintergrund zur Mikrowelle. So from now on, we will have the presentation in English.
Yeah,
and
it would be nice.
I will. I like to introduce to you before Alexander Bardenshtein from the Danish Technological Institute, and he's
Thank you.
responsible for packaging and logistic. And so just, I'll have to read it. So I'll take the risk. Yeah. I'm near the microwave, so I take any risk, so no problem. Being near the microwaves is not such a risk.
Not always.
Not at all. So just a few words. Who is pacoon? This one. Who is pacoon? We are based in Munich since 2001, so we are graphic design, packaging design agency, but we have to deal with packaging every day. So packaging is not only from the graphic side, also a very interesting and important side for us to know more about packaging, to know more about packaging solutions. We are experts in marketing strategy and packaging design. And we are not only covering regional, national, but also international clients, where we develop design and concepts and marketing strategies for the complete world. So just to give a rough introduction, and I will hand over to Alexander, who wants to explain you shortly something about the Danish Technological Institute, while I will put pizza into the microwave, so in 10 minutes we can see the result.
Yeah, thank you very much, Peter. Technological Institute in Denmark is a little bit older organization than pacoon, but it doesn't necessarily mean that it's better to be old. But we hope in our case it tells something about our experience. We are actually servicing Danish industry in many fields for more than 100 years. Our institute was founded in 1906 by a Danish engineer and entrepreneur, as we say in Danish, someone who organizes the business. So this guy, Gunnar Gregersen, he said, why don't we service small Danish companies with the cutting-edge technologies, which they cannot afford by themselves. And since that time, this mission is carried by our institute. Our status is that we are independent, not-for-profit. This means that what we have as income, we use for our development, we use for development project. We are approved as the institute to serve Danish industry with high-tech services by the Danish Ministry of Development and Research. And we address, as it's written on the slide, the needs of industrial sector and society as evolve through the development and dissemination of technological innovations of different kinds. We are located primarily in two places, Tostrup near Copenhagen and Aarhus on Jutland. And then we are also presented all over Denmark and in Sweden, in Poland, and... Okay, I understand. Yes, and also in Atlanta, United States, where we have our robotics department. This is our niche on the market. of the technological service. We are not where people look at something that is that it has to be decided whether it's possible or not technically. We are somewhere where it's already proven that it's possible technically. And we are as close to the implementation and commercialization as possible. And now I think we have to go to our presentation, and you will challenge me with some questions you promised.
I will ask you some questions, that right? And I just want to explain, because we have a handmade prototype here, which is a bit too big, which does not turn. So I had to open and turn it a bit manually, especially at the beginning and at the end, towards the end of the cooking. So that should be done by the packaging once it is industrialized. Usually you should not open it, you just leave it in for 10, 11 minutes. So Alexander, you have developed some solutions for microwave packaging. For how long are you working on such solutions?
The start was done by a Danish national project that was called Packaging for Better Meals from Microwave. Essentially, the target was to offer the Danish food fillers, packaging fillers, packaging and food industry, the solutions that would address the problems which people normally experience out of microwave and make food tastier, better, with a better texture, and so on and so on. So the project was financed by the Danish government. It lasted for 4 years, and the outcome was actually quite extensive. We managed to make decent packaging solutions for many kinds of food. And on the way, we managed to propose some solutions for big businesses, like, as you can see on this slide, to American enterprise called Hillshire Brands, former Sara Lee, who addresses the problems with the sandwiches to us. So that's our experience.
Okay, so we already know some packaging, as you show, which exist for microwaves. So why do you say that your packaging solution works?
The answer on the question why it works is actually rather simple. It works because you can see the results, and what is crossed by red lines on this slide is possible out of our packaging. But the reason is that we address some challenges which are present in the microwave oven for different foods. First of all, we look at something that is called inhomogeneous heating. We make packaging that makes heating homogeneous. We try to avoid the effect that is called thermal runaway. It's when you put something that is frozen in the microwave and give it a few minutes, and then you will see that part of your product is scorched, it's just overheated, and another part is still frozen. So this is exactly what happens sometimes when you put a bun in the microwave. In our packaging, it doesn't happen, and we know how to deal with that. Water pumping effect. You have seen soggy bread or soggy coated products like, I don't know, fish fingers or something like that out of microwave. We fight with that. We know how to deal with the water vapor transport in the packaging. And finally, we know how to make product crispy. It's because we look a little bit at the theory that is presented on this sophisticated slide. But this slide is both to scare you a little bit and to show you actually where the solution is. The solution is so that we have to achieve quite a high temperature in order to be able to brown and crisp our products within a short time span. If we can do that, let's say for 5 minutes, this means that we need to achieve a temperature above 170 degrees centigrade. And in order to do that, we need to use special packaging elements, special packaging materials, which are called microwave susceptors and heat insulators. Because otherwise, we heat air in the microwave, not the product. And finally, the next slide that shows why and how we achieve our goals. We consider the packaging for microwave as programmer developers would say packaging sharp. So this means, by analogy with the programming language C#, that it's a language, or in our case, packaging, conventional packaging for food, plus something else. And what else should be in the packaging for microwave? There's first of all, as I said, thermal insulation, because we need to achieve very high temperature in the packaging, and we don't need to heat the air around our product in the microwave. Another challenge is that we need to redistribute the microwave energy so that we have a lot of microwave energy where we need it and don't have where we don't need it. So that's why we use something that reflects microwaves. And finally, we use, as I said, susceptors in order to create this high temperature. The susceptors is a material, are the materials that gets very hot in the microwave field, and therefore able to radiate infrared radiation to heat the product by means of conventional heating processes.
So what is the main difference between a conventional oven and a microwave oven?
Yeah, well, as you may see from this slide, I'm happy to answer this question. When I say conventional heating processes, I mean, first of all, that the heat is delivered by three different means. This is radiative heating, just as, light, infrared light. The second way is convection, when the heat layer of air or water is substituted by the cold and so on. So that way, heat goes further. And finally, this is conduction of the heat. So all there is three means of delivering heat to the product, to cook it. They're available in conventional heating appliances, in the oven, on a fire, on your pan, on your cooking plate, but they're not available in the microwave. In the microwave, we have only one way to deliver the energy. From the magnetron to the cavity, the magnetron is a generator of microwave, to the cavity, and then in the cavity you have your product, and the microwave rays, they attack the product they impact the product from different directions. And then they are transferred into heat already in the product itself. But the air around the product remains cold. And this is a very significant difference. For example, this results in something that we call water pumping, that we have a cold air because condensation of the water vapor from the product happens at the interface between the product and the air. You have a soggy crust because your water vapor that was created by microwave is being condensed on the surface of your product.
So you want to tell us that you would be able to bake a bread within 10 minutes instead of 1 hour in a conventional oven?
Yes. 1 kilo of bread can be baked in the microwave in a packaging that includes different active elements within, let's say, 11-12 minutes for 1 kilo of raw dough.
We just did it before the presentation, and the bread is cooling down. So if you want to taste it afterwards, we are invited to just behind our stand, just behind the presentation in the middle, and you can taste the bread and consistency, which we did in 12 minutes.
That's right. Yes, the physical explanation is behind. This is actually how the microwaves are penetrated into the bread at different temperatures. In the beginning, you have a very high penetration when you have a relatively low temperature, and this means that electromagnetic radiation can form a very overheated zone in the center, in the core of the product. And then the water comes out in different directions. And then it's important to trap it there. This means that around the bread we have to create a hot atmosphere that would push the water inside. That would make the bread. So we need to substitute the cold air around the product by something. And this something is obviously hot air. But this hot air is provided by the properties of the packaging, not by the properties of the microwave oven. Because in the microwave oven, the air is cold.
So what kind of products could you prepare in the microwave oven?
Oh, that's a really difficult question, because in reality, you can prepare in the microwave oven almost everything you would prepare in your habitual home, domestic kitchen appliance, oven, pan, and so on. So the least is practically unlimited. You just have to use your imagination and ask what packaging you have to use for that. Everything is reachable. It's just a matter of applying research.
Yeah. So that would mean I just have to bring the right components together, and I can do whatever kind of product.
In principle, yes. You have to remember that it's not only right components, but also right combination of components that is specific for each product.
Okay. So we will see that in about 1 minute. What happened with the pizza? I hope that the timer is just enough. And so I guess that nobody of you would really expect a nice pizza crust from the microwave. And so how long does it take to make a pizza?
That pizza depends on crispiness you would like to achieve. I would say 10 minutes.
Okay. So we are just above 10 minutes, and we will see. Tell us, what is the fanciest product you would imagine to make in a microwave?
That's a good question. I would put it, first of all, that I would love to develop the products which are needed. One of the missions I can see for our development is development of food products for elderly consumers who don't really have a capability to cook anymore, but of course deserve to have a very high quality, tasty food. And one of the concepts I wanted to present here today is shown on this slide. Here you can see a traditional Danish dish. It's called tarteletter. Tarteletter med creme or kylling or so videre. Just to translate it to English, it's tartelettes with cream, chicken breast, meat, and mushrooms. Very delicious food.
Oh, big.
But you have to be a cook to prepare something like that.
Did you say big? No.
No, it wasn't me.
It was a microwave, I guess.
Okay, yeah. Good. Take it out. Yeah, this food I would love to make as a microwave packaging concept, so that everyone could put a prepared dish in the microwave packaging into the oven and get this delicious picture at the dining board.
I just want to show around a bit the
Okay,
result.
do that. Because
This is the pizza, and you see that the crust. Die braucht noch. Some people say it probably needs some more, depending on the crust. So if you would add 1 minute or so, it would even be more crispy. But we can taste it also. And
Peter, don't forget to mention the important thing that the topping of the pizza is almost as important as the crust, because you don't have to spoil what's on the top of the pizza. If you make cheese rubbery, if you make bell pepper that look like potato mash, then it does not attract people.
so it's not rubber. It's no gum. It's cardboard, yeah, plain cardboard. You would use corrugated cardboard, but we had to do the prototypes manually, and therefore we had to switch to this one. But we would rather use corrugated cardboard for this kind of packaging, and we would use a round one, so it would turn in the microwave.
I can almost smell the taste of another product which we have in mind. This is actually dessert. It's Belgian waffles with ice cream and chocolate. In fact, this product requires 3-zonal packaging. In one zone, we have simulate, let's say, an oven where we bake waffles. In another compartment, we melt the chocolate, and in a third compartment, we have ice cream that is shielded from microwave and remains cold. So when the microwave says bling, you can open the packaging and combine all these 3 components together, and maybe even these wonderful bears could be preserved in the microwave fresh as they are. Yeah, so let's
this
proceed.
product is obviously perfect for singles who just want to have a single portion instead of preparing everything in a higher quantity, which they had to do for today.
Singles, children, elderly consumers that would like to have a delicious dessert, yes?
So what
That's
about
right.
the sustainability and energy? I mean, you've
Yeah,
put a
that's
chart on what is the difference, main difference between microwave and conventional oven.
that's a slide that demonstrates actually how much energy you use to prepare, for example, bread or cheeseburger or chocolate cake in the microwave oven compared to what you would use when you do that in conventional oven. So you can see that the energy is enormous. You actually save a lot of energy. So this is one of the big pluses of microwave cooking, because what you get from microwave when you have a reasonable packaging for the food is actually accelerated cooking compared to normal oven.
So often people believe that the microwaves destroy the food. Is that the case?
What destroys the food is normally overheating. And actually, there were a lot of discussions about it, different experiments. But for ourselves, we accept this scientific research that has been carried out back in 1995 in Denmark by the order of the Danish Ministry of Health and Food Products. And this study was carried out in the Institute of Food Chemistry and Nutrition in Copenhagen, Denmark. And the study showed that basically microwave cooking does not deteriorate the food. Moreover, it retains important nutritional components because you cook in a shorter time at a low temperature. The main problem, as they figured out in their research, is that you don't heat homogeneously in the microwave. But this is exactly the problem we address. So basically, I would say otherwise it's very safe. You don't have to burn your fingers. This is the most dangerous thing when you cook in the microwave.
So if a company would be interested, either a manufacturer or a packaging deliverer would be interested in developing such a packaging, how much time do you think they would need to develop such a product together with you?
Depending on the complexity of the product and the packaging, it takes from approximately 1 month to 2 months. Exceptionally 3 months when we really need to go deep into the food texture and stuff like that. Just an example, we developed recently a concept for one small Danish company who is interested in baking bacon in the microwave, frying bacon in the microwave, to avoid dishwashing, to avoid all this awful smell when you bake pork bacon in conventional on a pan, for example, right? And we delivered a very sensible and effective concept within 3 weeks for them.
Okay.
So it's now in the production.
And to develop the handling and the convenience of the packaging itself?
I would say it's a bit more complicated matter. I would address it to you actually, because we found a Danish packaging design company who actually adapted our physical concept to what is convenient and what is looking nice.
Okay. So we, in the past, we once developed a pizza packaging. And that was under different constraints and regards. But for example, having such a nice plate with a foil to open easily and to have a nice presentation of it, would you say that something like this could be possible to do for such a packaging, which is now a bit prototype, handmade prototype, but could that be converted in such a packaging?
Certainly, certainly. I have no doubt about it, because I can already see what the tray can be. It can be either 3D molded cellulose, something like a cardboard tray, and on top of it we just need to put a multi-layer laminate that has all the necessary function integrating. Let's say it's a reflector, it's a susceptor, it's a heat insulating layer. So all these materials are available. It's just a matter to start and find a proper manufacturer.
Anything else you want to mention?
I want to say thank you.
So otherwise, let's ask the visitor.